Hello everyone, welcome to the channel. It's pivotal if you are learning AI to understand these papers which are coming forth almost on daily basis. I'm not asking you to go through them word by word, read all of them, but just to make sure that you're aware of what is happening in the industry at breakneck speed, it is imperative to learn at least at high level what these papers are all about. And that is why every now and then I try to include a paper which seems quite promising for the upcoming future technologies in AI. And when we say future upcoming technologies, I'm not talking about next year or maybe 6 months, maybe next month, or maybe in 2 weeks, you will see these sort of papers in action. And that is the beauty of this new field, which we are calling generative AI. This paper introduces a new method called as pre-training once for all, or POA, that enables training multiple models of different sizes simultaneously using a self-supervised pre-training session. This approach addresses the challenge of deploying large models to real-world applications with varying resources with constraints. POA uses a new elastic student branch that enables the training of multiple models with different sizes, which can be extracted from the pre-trained teacher model without additional training. For instance, if you look at this diagram, this is the overview of POA SSL. Given an image X, two augmented views XA and XB are generated. These views are input into three branches: a teacher, an intact student, and an elastic student, the latter being derived from the intact student. POA optimizes distillation losses in a twofold manner. The intact and the elastic students are distilled from the teacher using the cross-view data respectively, and additionally, the elastic student is distilled from the intact student using the same view data. In more simple words, what this paper is doing here is it is proposing a new paradigm in self-supervised learning called POA, which enables the pre-training of multiple models with different sizes using a single session. This approach is built upon the teacher-student self-distillation framework with an additional elastic student branch. The elastic student branch is designed to train multiple subnetworks simultaneously, which can be extracted from the pre-trained teacher model for deployment in various applications. And again, if you look at this diagram, this POA framework is consisting of a teacher, an intact student, and an elastic student. The teacher is updated using an exponential moving average or EMA of the student's parameters. The elastic student is derived from the intact student with shared parameters and is trained using both cross view and same view distillation. The cross-view distillation enables representation learning, while the same view distillation promotes the quality of the elastic student. The elastic student serves as an ensemble of multiple subnetworks which improves the representation learning and stabilizes the training process. So in this diagram, you can see that the KNN evaluation accuracy of 143 elastic widths derived from the WIT L16 teacher model pre-trained with this POA, which is really cool, I would say. This paper is demonstrating the effectiveness of this POA through extensive experiments using various backbone architectures including WIT, Swin Transformer, and ResNet. The results show that POA achieves state-of-the-art performance across multiple metrics including k nearest neighbors, linear probing, and downstream dense prediction tasks. Overall, POA provides a new solution, or should I say novel solution, for pre-training multiple models of different sizes simultaneously, addressing the challenge of deploying large models to real-world application with varying resource constraints. And because it is targeting real-world applications, that is why I'm quite hopeful that we will see it in action very soon. They also have a GitHub repo, but unfortunately the code is still not available, and this is what is, I think, the downside of it, where as you can see on this abstract they say that the code is available at this https url. Now let me open this https url and you would see that there is no code at all. So if I go down here, We have only readme and we have only license, and this was done last month, the license. So it's not that they have uploaded it just like 2 hours ago or yesterday. It was uploaded last week, the readme. But still, unfortunately, there is code is not here, and they say that the code is ready and awaiting company's approval. So hopefully it will be released soon, because looks really cool, and I'm seriously hoping that they would release it and we will test it out hands on to see how it works. That's it, guys. Let me know what do you think. Also, if you come across any interesting papers which you think I should cover, please put them in the comments. Very happy to review them, as we are all are learning together. If you like the content, please consider subscribing to the channel. Thank you.